Hello, and welcome to my talk, Boosting Suricata with Datasets. I'm Shivani. I'm a junior developer at OISF. I am developing parts of Suricata and all the helper tools like suricata-update, suricata-verify, suricata-socket control, and others if there are going to be any. And these are my social media links if you want to get in touch somewhere. So let's start with datasets. What is a dataset? It's a feature to match a sticky buffer against large amounts of data. Here is an example of the sticky buffer DNS query. And here we have an example of dataset. This is not exactly how a dataset file would look like, but this is just to demonstrate what exactly data sets could comprise of. So here we try to match DNS query sticky buffer against all of the URLs in the dataset. We can define datasets two ways. We can define them within the rules with the dataset keyword or with the configuration suricata.yaml under the datasets key. So here we have an example rule for DNS query again. Here we are using a transform and then a dataset. We are checking if a particular dataset is set and if the type matches what we were expecting, and that we load all the dataset values from this particular file. If we were to write a similar fashioned configuration for dataset in suricata.yaml, we would write it like this. We would define all the dataset. We can define a list of datasets with this hyphen thing in the YAML under the datasets key, and we can define the type and the state or any other options that we would like to be here. There are three dataset commands. The first one is set, which is used for setting a value in a dataset. It returns false if the value was already there in the dataset, or true otherwise. This is helpful in the cases where we are trying to find out first occurrences or unique somethings. We are going to, moving forward in these slides, we are going to come across a few examples comprising of set and the situations where we can use it. Then there is set command, which, as the name suggests, checks if a value is set or not in a data set. And there is not set command, which does just the opposite of is set. There are several options available with datasets. The first one is type. This is pretty important. We have to give the dataset a type, the value a type. It could either be string, MD5, or SHA-256. Then there is load option, where we give the name of the file, the dataset file, where we want to load the data from. There is state option, which sets the file name for loading and saving a dataset. There is save option, which we use to save in-memory data if Suricata exits. There is memcap option, which we use to define the maximum memory limit for that particular dataset. And then there is hash size, which allows you to define the size of the hash for that dataset where you are defining this. Now, there is something called static and dynamic sets, mostly based on the way they behave and their properties. Static sets would be something that has load command, is defined in rules, is reloadable via unix-socket, and is not expected to change during runtime. The last point is exactly why its name is static set. And dynamic set is not exactly opposite of it, but yeah, pretty much. We have state or save command here. And this is defined in suricata.yaml. And this is not reloadable via Unix socket. However, you can manipulate data sets, the dynamic data socket, as we're going to see in the next slides. So here we have a small GIF that demonstrates how we can control data sets, manipulate them using Unix socket. So there are these two commands available for datasets, that is dataset add and dataset remove. They do as the name suggests, and you can run them via suricata socket control. And both of them expect the name of the dataset, the type, and the data, the exact data that you want to add or remove in a particular dataset. The expected file format for a dataset is just a regular file with each entry on a new line. The content should be encoded to avoid running into issues with special characters. This is something that we need to take care of, especially with the URLs, with so many different things being there. This is an example of a bunch of URLs which we want to be a part of a dataset list. So in order to do it the right way, we would first encode them. The base 64 is not necessary, but this is one of the encodings that is commonly used. We encode them to base 64, and then finally the product on the right that we see is what is fed to Suricata when Suricata tries to load the dataset. And each individual URL here that you see on the left is individually base 64 encoded here on the right. So this is what the file format is supposed to be. So we can manage datasets easily with suricata-update. We don't really have to do anything special. There is no special command or option or anything for suricata-update to do anything with the datasets. If there is a particular rule set that comes with datasets, it would download the dataset file, the rule file, and it will put all of it within the expected rule directory. This feature has been available since Suricata 1.2.0, and you can find and try to use it. This is one example of the management with suricata-update. Here I have a rule file that has a dataset rule and a dataset file hosted on my local server. And I tried to fetch the rule from there with suricata-update. Nothing in particular, nothing new, just the URL option, and I provided the localhost link where it was hosted, and you can see it loaded one rule, it downloaded a file, and then it tries to copy the dataset file to the output directory where the rules also exist so that it does not break any reference. There is some little trivia here about datasets now. So this was introduced as an experimental feature in Suricata 5.0 by Victor Julian. It was then later launched as a stable feature in Suricata 6.0. There is also something called data rep that matches on a reputation list instead of a data list like we do with datasets. We can, the datasets can take custom file path within the rule. So when you define load keyword in the rule, there you can mention a custom file path as well. It does not necessarily have to be in the same directory. You can also set memcap and hash size within the rule as well as within the configuration suricata.yaml to avoid running into memory issues. And the thing that one thing that we need to understand is that any match done within the datasets would be an exact match. So substrings won't be matching, but there is always a way. It seems for most cases, like we have been coming across a problem on our forum recently about matching on subdomains with datasets. So that is not directly possible, but there are ways to make it happen. I'll cover that later in the slides in an example. Here are a few use cases that I know of. You can use datasets for making deny list URLs, allow list URLs, unique identifiers on your network, And there could be, I'm sure, much more interesting use cases. So if you have any of your use cases, please let us know in the chat. So here is one example for detecting unique user agents. Here the rule tries to use dataset over the HTTP user agent sticky buffer, and it tries to set a particular value on this dataset of type string. Now here what it essentially is doing is it tries to set whatever value it got in the sticky buffer HTTP user agent to this dataset. If it got set, it means it was not pre-existing in this dataset, and it returned true that we were able to set the value in the dataset for the first time. Now, because it returned true, you get an alert for this thing, like shown here, because this is a new user agent in your network. If it was pre-existing, then it would already be present in this dataset file. Now here is an example of detecting unique TLDs. Suppose we want to see in a network, every time we want to alert when there is a new top-level domain. So what we essentially do here is we are using a DNS.query sticky buffer, and we try to see if the TLD is already set or not with respect to a dataset file. But we just learned that with dataset, anything is always a perfect match or it's not. It either matches completely or it does not. So what we can do is we can use this PCRE transform keyword, and we can use it to modify our sticky buffer and then use the data set on that, on the result of that. So here in the diagram, if you see, if the DNS query consisted of www.xz and the rest of it, we applied PCRE transform on it with this regular expression, and the result of this was CN. Now we check if CN already does exist in the DNS TLD scene dataset. If it does, it's not a unique ID, so we get a false and we get no alert here. However, if it does not exist, it is set in this particular data set and we get an alert that, hey, we found a new unique TLD. Now, there are some caveats with datasets. It's either it's binary, either a dataset value is set or not. We cannot do other operations on that. AWS Network Firewall does not support datasets. Dataset file path should be either a default directory or an absolute path. Suricata-update was recently got a bug report that it cannot manage datasets if the rules were loaded with local option. So this is not possible yet, but we are working on it. So you can try it out. If there is something else that needs to be fixed, please let us know. So special thanks to my mentor and lead developer, Victor Julian, for teaching the concept of entire data sets and helping me with all the contribution that I made to data sets and this presentation altogether. And Peter Manev, who is an all-rounder superhero. He helped with a lot of practical exercises and insights that for this presentation. So thank you very much. And thank you. That's all. You can read more about datasets on official docs of Suricata, suricata-readthedocs.io. And if you have any questions, now would be the time.